Hi and welcome back. In this video I wanted to tell you a little bit about some interesting Python collections that come built in with the language that you can use for a few different things. So the main purpose of this video is to make you aware that these things exist. Because once you know they exist, later on you may find a situation where using one of them could be useful. Again, going with the analogy of the tools and the construction project, I'm just giving you a few more unorthodox tools that nonetheless could be useful. Normally what happens in one of the situations where we could do with one of these tools but we don't know about them is that we have to work really hard to build one that works well. Instead of doing that, you can just use one of these. So, let's get started with the first one. The first one is going to be a counter. A counter, as you can imagine, allows us to count things. So you can give it an iterable or a mapping like a dictionary, and it will turn it into a counter of elements so you can count how many there are pretty easily. Again, how you do is from collections import counter, and everything we're going to be looking at in this video comes from the collections module. These are some pretty useful collections. Feel free to look up the Python documentation if you want to learn more about these or others that are there. And what we're going to do is say something like device temperatures is 13.5, 14.0, 14.0, 14.5, 40.5, 40.5, 15.0 and 16.0. Let's imagine we've got some sort of thermometer that's been doing some readings and we want to find out what the most common temperature of our system is. We could do some really contrived thing where we loop over it, we keep track of the ones that we've already seen, we increase one every time we look at it. Generally, I mean, that's just giving me a headache just thinking about it. So instead, we can do temperature. Counter is going to be a counter of device temperatures. And then we can print temperature counter 14.0. So access it as if it were a dictionary. Just access the key that you want to get the count from. And you can see that it gives you 2. And if you go for 14.5, it gives you 3. Pretty simple counter. You can give it a dictionary as well, and it will also turn it into a counter of things. So, for example, you could have a counter of greetings, how many times something has been said. Let's say hello has been said 5 times, hi has been said 3 times. Then you can access a particular one, and it will just tell you again how many you've done. So here again you get the 3. This one's not that useful. The official Python documentation uses this example. I'm still not 100% sure on why you would do this. After all, you do have the counts here. You don't need to wrap them in a counter for anything. But I can see the usefulness for a list. So who knows? Maybe I'll find the situation where doing this is useful later on. But I've not yet been able to use a mapping, a counter mapping, for anything professionally, but I've used this and it can be quite useful. Okay, that's the counter. Very simple. Again, if you want to learn more about counters, feel free to check out the official Python documentation. It'll be in the further reading lecture of this section, so feel free to check that out. Now, the code for this video will all be available all together, but I'm going to just delete it and go over to the next collection here just to keep things a bit simpler. But the code will have each counter. Sorry, not each counter. We'll have each collection all in the same page. So let's move on to default dict. As we know, when we have a dict such as this one, hello, was said 5 times, for example, and we print my dict hi, we know what's going to happen when we do this. It's going to give us an error. And indeed, as you can see here, we get a key error on hi because it doesn't exist. The default dict never raises a key error. Cool. So that's not it though. Instead, it returns the value returned by the function specified when the object was instantiated. Whoa, that was a mouthful. Let's do some code. From collections import default dict, and what we're going to do is we're going to have a list of co-workers and where they studied. So here we've got a list of tuples, where the first element of the tuple is the name of the coworker, and the second one is where they studied. So you can see Rolf went to MIT, Jen went to Oxford, Rolf then went to Cambridge to do a master's degree, and then Charlie went to Manchester at the end. Now, let's say we wanted to create a dictionary that maps names to where they've been. Something like this. Rolf went to... oh, sorry, I forgot the colon there. Went to MIT and Cambridge. And then Jen went to Oxford. And then Charlie went to Manchester. Manchester. There we go. Imagine we wanted to make this dictionary, but we only have this data. So an option would be to go over each element and put them in a dictionary. Something more or less that looks like this. We'd create our dictionary, alma maters, which just means places where they've studied. Then we would iterate over our coworkers list in coworkers, there. Now remember, coworker is now a tuple. 0 is Rolf and 1 is MIT. So we would say alma maters coworker 0 is an empty list, first of all, and alma maters coworker 0 dot append coworker 1. So coworker 1 is MIT, and what we're doing is we're accessing the Rolf value of our dictionary, which has just been initialized, that's the word, has been initialized to be an empty list, and we're going to append to that empty list the place where he's been. Now this works fine as long as they only appear once. The first time they appear, in this case Rolf, we initialize it to an empty list, and then we put MIT in it. Then we do the same for Jen, we initialize her to an empty list, and we put Oxford in. But then we come back to Rolf, and what we do is we once again set it to an empty list, so we delete MIT, and then we append Cambridge. So we couldn't do this. What we would have to do is say something like if coworker 0 in alma maters, not in alma maters, set the value to the empty list. And if they are in alma maters already, it means we've done this before. We can just append to the list that we've already initialized before. Not the simplest way of working with code. Of course, we can make it simpler by destructuring the tuple here and just say coworker, place. Saves us from accessing the indices separately. We could do this. Of course, this editor removes closing brackets for you, which is not a great feature. So we could do this a bit better, still not brilliant. And as you can see, what we're doing here is also, once again, something that's very common to do, which is to add things to a dictionary if they don't exist yet, and otherwise treat them as though they exist. So what we're doing is, when we don't have an element in a dictionary, we're going to set some default value for it, and after that, we're just going to treat it as though it's already there, for example, appending to the list. Naturally, the default dict is here to save us. We can do default dict list. List, remember, is a type. When you have something like this, that is of type list. And therefore, because it's a type, it's a class. Classes and types, same thing. All things in Python are classes and objects. And so this is a class name. Therefore, it's a function as well. And remember, we can call our user constructor when we initialize a new user. It's a function call, essentially. List is also a function call. And I said earlier that the default dict takes in a function. This is the function that it takes in. And what happens is, when we try to access something that doesn't exist, like Rolf, it gives us the result of this function. So it gives us a new empty list. That's what this function does. It gives you a new list. So it gives you a new list, and then you can append to it. It does exactly the same as before, only now we have a bit less boilerplate. So we can do something like print coworker, alma maters. Alma maters Rolf, that should print out 2 things. Print alma maters Anne, and that should print out 0 things. Let's run it. And as you can see, we get MIT and Cambridge for Rolf. And for Anne, which didn't exist, we didn't have her in her list here. We just print an empty list because that's the default value for anything. Okay. Now, if you wanted to raise an error or potentially print out none when you try to access something that doesn't exist, you can always do alma mater's default factory equals none. And notice how then you get a key error, because now you've removed the default factory, which is this list, and doesn't exist. But Rolf does, so you still get the default factory working in this bit of code here, just you don't get it working after this line. So this is a nice tidbit here, in case you want to remove the default factory and not just be returning empty lists for everybody. Okay. And similarly, you can, of course, also do alma mater's .default factory is now an int, for example. Then whenever you try to append, it will give you an empty integer, which is 0, the value 0, and it will fail. But you can do things like, do something else with an int with the number 0. You can change the default factory, is all I'm trying to say, from list to dictionary or tuple or whatever you want. Okay, let me give you another example. So I'm going to delete all this stuff here. And let's say I've got my company, which is called Teclado, and if you don't know it, shame on you. Then we've got our co-workers, which let's say are Jen, Lee, Charlie, and Reese. Some of these are actual co-workers of Teclado. Other co-workers, those are co-workers that don't work at Teclado. We are going to say they are, for example, these tuples of Rolf and Apple Inc. Lucky guy. And Anna is going to be working at Google. As you can see, these two have different structures. For my co-workers, I already know where they work. I only have a simple list. Potentially a tuple could be better. It doesn't matter. For my other co-workers, I've got a list of tuples where I define the name and also the place they work. So, what to do is define a place like coworker companies, and this is going to contain something that is going to be like this. Jen works at Teclado, Rolf works at Apple Inc., and so forth. So a mapping of names to the place they work. How to do this? Default dict, lambda, my company. My company is this variable Teclado. This is a lambda function that doesn't take any arguments. There's no x before the colon, or no parameter name before the colon. Doesn't take any arguments. Always returns my company. Why can we not just set my company there? Because the default dict takes in a function. So we have to set a function that will be called when we access the key that doesn't exist. Then we're going to do for person, company in other coworkers. We're going to say coworker companies, person equal company, and that's it. Oh, no, not that one. There. Now, we can do coworker companies, coworkers 0. Remember, this is going to be Jen, our coworker from Teclado. And we can also print coworker companies of other coworkers 0. 0. So this is going to be Rolf. In order to simplify things, I'm just going to type Rolf in here. Now we can run this. And as you can see, we get Teclado for Jen, and we get Apple Inc. for Rolf. Rolf and Anna are actually in this dictionary when we finish the for loop. Jen, Lee, Charlie, and Reese are not in the dictionary, but whenever we access them, we get the value returned by this function, which is Teclado. So this is a slightly more contrived example, maybe not a terribly useful one, but nonetheless, this is how you use a default dictionary. I wanted to give you this lambda example here in case you want a default value that isn't initialized by a function. So just remember, you can use a lambda function here. That's fine. You can use lambda functions anywhere where you can use normal functions. So what we've done here is created a mapping of the other coworkers, and then we can also access it for our own coworkers because we know where they work already. Okay, that's it for this video, for this collection, the default dict. We're going to move on to ordered dict. So let's do it. The ordered dict actually is a bit of a bizarre one because it has the capital letters. So just remember that. Remember the capital letters. Ordered dicts, not so useful. We're gonna look at them more quickly, just because they're going away soon, I think. And so as you can see, we are just accessing normal keys as if this were a normal dictionary. We're setting the values in those keys to 6, 12, 3. Then we can print them out. And what you'll see here is an order dict where the keys here are Rolf, then Jose, then Jen, and the values are 6, 12, and 3. Important is that they are in the order in which they were inserted. It does not mean they are ordered alphabetically or anything like that. It just means they're ordered in the way they were inserted. So Rolf was the first one we added. Rolf is always going to be the first one there. Okay. You can also do O.move to end Rolf. And that is going to move Rolf to the very end of this dictionary. As you can see, Jose is now first, Jen is second, Rolf is now at the end. You can also do O.move to start. My bad. I wish that was the case. Move to end Jose, but now last is false. And instead of it being the last, it's going to move it over to the other end, which is the beginning. But I'm going to move Jen, of course, because Jose is already the first one. Now you can see that Jen is the first one, Jose is in the middle, and Rolf's at the end. Okay. Something else you can do is pop item. And this is going to give you a new dictionary where the last item has been popped off, has been removed. So pop, pretty popular programming term. It just removes an item, and it normally removes items from the end. And so that's what we see here. We've popped off the last item in the dictionary. So I don't think order dict is going to sort of really go away, going to be deleted from Python, but it's not so useful now because as of Python 3.7, dictionaries themselves are going to be retaining the order in which they are inserted. So it's going to be slightly less useful, the order dict. It's still useful to keep these functions, move to end, and move to start, and pop item, and stuff like that, which isn't in normal dictionaries. But the fact that they're ordered is going to be less important now, because in Python 3.7, as I said, normal dictionaries will start keeping the order. Okay, let's move over to the next collection, and that's the named tuple. I gotta love this. Named tuple. I love the named tuple. And the named tuple is another object that we can use just like a tuple, but each of the elements has a name. And in addition, the tuple itself also has a name. So it improves on tuples by making things a bit more explicit. Let's have an example here. A checking account that has $850.90 in it. We can print account 0, and we can print account 1, but it's not so clear what these are unless you're looking at a tuple. If the account was being read from a database and the code was a bit all over the place, you wouldn't necessarily know what account 0 is, which is, of course, the name. And you wouldn't necessarily know what account 1 is, which is, of course, the balance. Maybe you'd think this is the overdraft amount. Maybe you'd think this is some sort of tag for the account. I don't know. You could think anything because it's not terribly clear what they are. If you wanted much more clarity, you could create a class for your account and have a property called name, which was checking, and a property called balance, which is the balance. Or you can use a name tuple. So we're going to define a new name tuple. Notice how I'm using capital A here. And this is going to be a new named tuple. The first parameter is the name of the tuple. And that has to be the same as the definition here, account. That's because of the way Python works. It can't quite see the name of the variable first. So this name here has to be what you want your type to be. Then in a list, we're going to define name and balance. So these are the two fields on the tuple. The first one is checking, and the second one is the balance there. Then we can do something like account is account, checking, and 1850.90. So as you can see, now we've used this named tuple instance to create a new instance of this type account. It's essentially the same as a tuple, except now we can print account.name, for example. We can use the field names. And indeed, we can also print the account itself if we want, and that's it has a nice representation, a nice dunder repr method here. I like to think of it very much like defining a class, where account is the class name or the type, but it's not quite the same. Name tuple is still a tuple after all. You don't have any custom methods that you can define in a class. So it's like a nicer tuple that allows you to be a bit more explicit with what things mean. That's the word. You can still do things like name, comma, balance is account. Tuple destructuring. You can still do tuple destructuring. When you define the account, you can have, of course, named arguments in here, like you can in any function. You can use positional arguments like the checking here, or you can use named arguments like here. This makes things much nicer for you to be explicit in what it means when you create a new account. Given a tuple like this account here, you can have an account named tuple, which is account._make account. So this is the type. ._make takes in a tuple, and it will associate each element here with the respective field. This is particularly useful for when you're using the map function. Otherwise, you can, of course, do this, and that is the same thing. You can also turn an account name tuple. You can do as dict. Let's print that one out for you to see what that is. You can print it out as an ordered dictionary where it keeps the field orders. Name goes first, balance goes second. You can get it as a dictionary. You can then, of course, access it as a dictionary. You can use this square bracket notation there, and that gives you the number, 1850.9. So it's a pretty useful thing when you're dealing with data and it doesn't warrant creating classes for the data elements you're working with. Like, for example, when you're reading from a database, you're reading from a CSV file. Name tuple is a great choice, and it's really flexible, and it just makes things more explicit and more clear with what's going on. So definitely something to keep in your arsenal. I think it's pretty nice thing to use, so definitely remember it. Also, the guy that made this, Raymond Hedinger, is a pretty cool guy. He makes a lot of nice Python talks, so what he's made here is useful. Let's move over to our last collection, and I know I'm boring you already, which is the DQ. The DQ stands for double-ended queue. So please watch the presentation about queues. If you haven't done so already, it's just the video prior to this one. And in a double-ended queue, it's just like a queue, but we can push elements from either the start or their end, and we can also remove elements from either the start or the end. It's very efficient, it performs very well, and it's just essentially like a list, but you can append or prepend, start and end, and you can pop from the start and from the end. The most important thing about the DQ, and the main reason why we use it sometimes instead of a list, is because of its efficiency, first of all. Secondly, because it's thread safe. So you can use DQs when you're dealing with threads. And we're going to look at threads very soon. I know that we've not looked at them yet. But essentially, a DQ is really useful when you're dealing with threads, because all its operations are thread safe. So when we look at asynchronous development, we're going to be looking at the DQ a bit more. For now, just remember it's like a list on which you do operations that are very much like a list. So for example, friends can be a DQ where they get, let's say, Rolf, Charlie, Jen, and Anna. And then you can do things like friends append, Jose. What is happening in the DQ constructor is you're passing it an iterable, and one by one it is appending them to itself. So this tuple here then gets turned into the DQ objects, or the elements of the DQ. You can then append to it. You can do like friends.append left, Anthony, for example, and that Jose will appear at the end of the list, of the DQ rather. Anthony would appear at the start of the DQ. And you can also do friends.pop, that removes an element from the end, or you can do friends.pop left. Append left is with a capital L, my bad. You can do friends.pop left, that removes an element from the end. This one removes it from the start. So these are a couple of things you can do just to show you. You can print friends, and you can print friends here. And then see that you get the DQ here with all the elements, and then you've popped one off each end there. For more info on dequeues and a comprehensive example on everything you can do, check out the official Python documentation. It is linked on this lecture as a resource. And so have a look if you are keen. If not, when we move over to asynchronous development, we're going to be using it a bit more, and you'll sort of understand why we use it instead of a list. So that's it for this video. I hope I've not bored you too much with these collections. I just think they are really useful tools to keep in the back of your mind, and at some point you may need them. So it's always a good idea to remember that these exist. When you do need them, just know, I think something like this existed. Let me have a look at the official Python documentation and see if I can find it. And then you'll be able to find it. If you don't know it exists, you're going to have trouble. You're going to be trying to recreate your own double-ended queue instead of using the one that's already provided, and it works, and it's tested, and it's validated that it all works. So that's it for this video. Thanks for watching, and I'll see you on the next one.